Good afternoon everyone, and welcome to this Solid Edge clinic. In this clinic we'll be looking at the new release of Solid Edge ST5. Thank you all for coming back. We've had about a four and a half month hiatus in our Solid Edge clinics, but our intention is to be running those regularly again every 2 weeks, and keep watching for new invites. The video replays of these clinics will be available on our website. You'll need to log in to our online support area, and it's worth noting that they're available in high definition. So let's get a move on. What are we going to be talking about today? It's the high points of ST5. We've got somewhere around 1,300 changes and improvements to ST5, so we're not going to be covering all of those this afternoon. We're just covering the high points. You'll get more detail over the coming weeks. As I said, there'll be a clinic. The next clinic will be on our Multibody, which is new in ST5, and today we'll just be providing an understanding of the high points and what they are and how to use them. Just a few statistics. When you register for this webinar, I ask you some questions, and here's the results. We've got 50% of our users are on ST4, which I expected to see, or a large percentage, but 32% are on ST5, and that's gratifying to see. It's only been available for a short time, and that number's growing quite quickly. I notice that we've still got a number of people on ST3, still a few on ST2, and we got a handful of replies that people that didn't reply to the usage. So it'll be interesting to see how that changes over the next couple of months. Okay, let's move on. We'll be looking at just as I said, the high points, and flexible modeling is one of the key areas for ST5. In that we introduce a whole new subsection, which is multibody modeling. Just by way of explanation, if we look at these two tables here, the top one is a normal assembly. We see all the parts in there, and the bottom one is a single entry body. It's just a single part that encompasses that assembly. It works in synchronous and in ordered. You can import assemblies into single part files, and there's some tools to help you overcome the non-manifold problems. You can merge or split parts, so you can design a multi-body part and then split it up to make an assembly. You can add new parts to continue design. You can publish for drawing production. You can publish back out to an assembly and to make drawings and bills of material and what have you, if you want to do it that way. We won't be looking at that today, but another area to simplify your design process is the ability to have more part operations from within the context of an assembly. At the top level of the assembly, we can add some key features to parts. We can edit most features that are there without having to go down into the part, and we can delete any feature. This applies to synchronous. If we look here, we can see we've clicked on an edge here. The grab and go handle comes up. We can either edit the feature by extending that flange up, or we can create a new flange by pulling on the flange start handle. This is without going into the part. We'll have a look at this as we go through. Another new area is slots. This looks very simple, but there's a lot of detail available in here. The slot is a procedural feature, which means that when you select the slot after it's been created, you can get back all the dialogue that created it, its sketch and everything else. So it's very flexible to edit. Again, it's available in both traditional and in synchronous. Very powerful feature, and it creates a path that you can use as for assemblies later on. Just remember that that we'll do a little bit of that later on. Another innovation with ST5, hole recognition. This is a new one. If you're importing parts, holes come in as just dumb bodies. They have no intelligence in them. This allows us to recognize the holes and make them a hole feature, which is a procedural feature, which is completely editable. Very, very powerful tool. It's under the hole icon. you'll see slots there, and we've got recognize holes. It just goes and finds all the same holes and groups them together and puts intelligence on them, so you can easily edit them. I mentioned before with Multibody Modeling that there's some tools for enhancing the way that we handle imported geometry. Geometry Inspector has been enhanced to be able to find and heal body faults, which is extremely useful. And we've added a new tool called Geometry Optimizer, which actually cleans up and simplifies some imported geometry that gets a bit, what's the technical term, hairy on import. The upshot is that these two tools allow you to very easily import models and prepare them for synchronous edit so that things work as expected. Some very, very useful tools. Again, a new area, dimensioning. It's something we've had for a long time, obviously, but we've done a lot of work in dimensioning to push the design intent through to the dimensioning tool. And what I mean by that is that if you select, we know with a dimensioning tool in synchronous that we've got the arrows. You'll notice there's another arrow in there now. I'll talk about that in a moment. But we've got our left and right arrows. It's very easy to open up a dimension, not look at the arrows, make a change and say, oh, that's the wrong face. What it does now is if you select a face at some point in time, it remembers that face. So I always want to modify this face, for instance. The next time I open that dimension for edit, it will remember it's that face. The other type we've got is a symmetric edit, which allows a local symmetry. So in the symmetric edit, when I edit this value, it applies an equal amount to both sides. Again, if I select that, next time I select it, that will be there. In sheet metal, when we've got dimensions that are placed to bends, they remember the relative position. Bend angle edits work either to intersections or to silhouettes. You can pick that, which is very useful. Those of you who attended my webinar, I think it was late last year, on or early this year, I forget, on the steering wheel and live rules, will remember the advanced edit function that we looked at that allowed you to control precisely what was going on. Excuse me for a second. Sorry, just had to cough there. That's been modernized significantly. It's a thing we call Solution Manager now, and this happens automatically, and it allows us to examine what's going on from the graphical user interface rather than having to go into tables and look down through things and find out which faces belong to which. We can do that directly on the screen, and we'll do a demonstration of this, and it'll make it a lot clearer for you. Speaking of which, let's start up Solid Edge and do a demonstration. So first off, what I'm going to do is we're going to focus in here on this little sheet metal object here and switch to face select that face. You'll notice that I can extend that face, which is something I could do before, but now, let me get back to the face, sorry, I've got the flange start handle. So I'm going to build a flange on that, and I've got all my flange controls here at the bend outside, and I'll just go down to that key point just there, and that's placed a flange for me right in the top level of the assembly. I don't have to be in the edit mode. Let's now, however, edit that part, and I will go to my radial menu and hide previous level. First thing I'm going to do is to put some close corners on here, again from the radial menu. Just picking the corners I want to close. Using the radial menu does speed things up for you. Again, a dimension here. I'm going to place a dimension on this edge here. We'll just reposition that a bit so you can see it a little easier. Okay, I've got my arrows. I want to modify the back face here. We want to make that, say, 120. Not 12. 120. It wouldn't actually do that for me. So it says OK. Let's do that again. Move that away so you can see it. Okay, we've made that 120. Now, the next time I go back in, notice that regardless of where I place my cursor, it's pointing towards the back face. So when I select that, we notice it's pointing towards the back face. I want to make that 130 in this case. Okay, we can see how that's useful. Let's have a look at this other dimension here. Now when I select this one, I don't have any arrows at all. Why would that be? Let's take a look. Down here in our relationships, I've got a grounded face. I've got some grounded faces, but specifically, this face to which the dimension's attached is grounded, which means it cannot be changed. So that when I select the dimension, it can only move it in the direction of this arrow. It can only move that face. It can't move it symmetrically. It can't move this face. So it doesn't give me the choices. So I cannot get it wrong. In this case, we want to change this to 280, I believe. Not 28, as I was about to type. Okay, let's have a look at the other end. We'll notice that this part is not symmetrical. We've got our base coordinates down here in the corner. Now, if I select that dimension, it's been selected before to be the symmetric dimension. I can do that either way, but I want the symmetric. Now, when I do a symmetric dimension, what it's going to do is apply local symmetry. Let me just roll the cursor and you can see that happening. Pretty smart. Let's make that 120. So what we've seen is I've got live rules turned off. Me playing around. Turn the live rules back on. Now it'll work a little bit better. And we can see it applying local symmetry to the faces that are in the select set of the dimension. So let's see why that's happening. Why is this changing? You can see it's in blue, so it's being updated, this face here. Well, it's because it's coplanar. So if I click on that rule, turn that rule off and turn it back on again, you'll see it updating. So let's make this 120 as I wanted before. And let's hide the PMI for the moment and work directly with this face. What I want to do is move that out by 25 millimeters. It helps if I could type, wouldn't it? Now, it hasn't made that change, and we've got some colors have come up, and we need to analyze what's going on. First thing we see is black, or I notice is the black. That means that those faces are grounded. They cannot move. They'll stay where they are. So a dimension can't change them. You can't drag them. We see some a green face. That's the face I selected to move, and you can see that I've got a 25 millimeter move on there, which hasn't happened. You can see where it was going to go to in orange. We've got some light blue faces. It means those faces are behaving as we'd expect. They will move with the change that I make. But these orange ones aren't, and I need to find out why that would be. Now, there's several things I can do. I can relax a dimension here. This dimension is locked. These orange faces won't move. So if I click on the dimension, it will unlock that dimension. If I accepted that by a right click, it would relock. It makes the change, adds 25 millimeters to the dimension, and relocks the dimension. That's not what I want to do. But I want to find out what's going on a little bit more. So if I select a face and right click on it, I get the rules that are being applied to that face. We can see here a tangency, and if I touch on there and slide across, it will show me the relationships. You'll see when I highlight that icon, those tangent faces light up. The concentric, I'm not clicking anything here, I'm just hovering. If I go to the concentric, it'll show me what's concentric. Again, it brightens up that circle. If I come down here to the found relationships for coplanar axis, you see the face at the bottom highlight, and again tangent, the other tangency that's on there. So these allow us to manipulate these relationships directly. We can also see them if we come down to the icons on the live rules area. When you hover over those, you see the faces that are being affected by them light up. Now what I want to do is to say, well, I don't want to move the holes. So what I'm going to do is, you notice when I hover over the hole I get a little minus. If I click, it takes that hole out of contention. I want to take this hole out of contention as well. So it's moved the faces but left the holes. You'll notice the holes are in red, which means that you've frozen those in position. Right click to accept, and it's made that change for us. Let's close and return to our assembly and zoom out a little bit. No, I don't want to return to the assembly just yet. My apologies. Go back to edit. There's one more change I want to make in here. I have a sketch in there. If I turn the sketch on, what I want to do is put a slot on that sketch. So let's have a look at the slot command. I've got it on my my wheel, and I just select the sketch and say which way does it want to go. I've got a dialog box up here, so I can set the width. I can have a flat end or an arc end, and if I'm dealing with parts I can have counterbores and recesses and those sorts of things. I can say 20 is fine, that's what I want, OK, and click to place it. Now when I close and return, I've got my my slot in the part here. There's one other thing I just want to show you while I'm talking about slots. Just let's have a look at some more slots. So again, I've got a part here, so it's not sheet metal, we've got something a little different here. I'll select the slot. Which way do I want to go? Again, let's have a look at the dialog box before we do anything. I want to make this one 4mm, and I want to do a counterbore, but I don't want to have a recess. I want to raise this, so it's 1mm and 1mm. Say OK to that and push it through. Again, you've got the same command bar comes up, the slot extents, or the normal thing I want through next, and there we go. Right click to accept that. Now if I come back and select this later, you'll see it says slot 5. It's a slot. I can change the width, the path offsets and things like that. Let's change the path offset to 2mm, which means it's this raised bit offset is going to change, and we see that update. Okay, let's come around the back here and get back to slot. I didn't mean to get out of that. And pick up my slot here. I want to go downwards, but let's change the dialog for the moment. I want to do a recess, say OK to that, and come downwards. We can put another one in. Right click to accept, and back to the command, one in here. Even though it's partial, it will cut through as we'd expect it to do. It's pretty simple, this thing, but it's a powerful command, and we'll see a little bit later on that it creates a path in here, and the path relationship in assemblies is quite powerful. Okay, back to the slides, and one of the things that we've added with ST5 in simulation is steady state heat transfer, which is new for ST5. Just remember, simulation is an option which is available for Solid Edge as an add-on. You can purchase an add-on, or you can purchase a product called Solid Edge Premium that comes with the simulation available. I can talk about this, but it's a steady state heat transfer. Let's take a look at it. It's probably the easiest thing to do rather than witter on about it. What I've got here is just a simple cylinder that I wish to do a study on. Now if we go to our simulation, I'm going to create a new study, and under my study types I've got my normal linear static, normal modes, or linear buckling. In this case I want steady state heat transfer. I'm going to turn this off because I want the full results, not just a surface result, and say OK. Now I'm going to place a heat flux onto the inside face here of say 10 watts, and you see that's going into my loads here. There's my heat flux, and I want a convection load for the rest of the body except for the inside, so I control select to get the inside out, and I'll leave it at defaults. You'll notice that the ambient temperature is set in degrees Fahrenheit. It's English unit part. So we don't need to display the loads. That's the only thing we need at the moment. There's no constraints needed for heat, so I'm going to do a mesh. Now in meshing, what we see is we've got now a slider, which we've always had, but it tells us the mesh size, a subjective mesh size. So when we do the mesh comes up, this is the distance between the nodes. 9.74 millimeters, and that'll change as we do the slider. Okay, let's solve that, and we'll see what sort of results we're getting. It'll be in degrees Fahrenheit, of course, the loads. We can have a steady state temperature on this as well, and we can have radiation both enclosed and free space. Okay, we can see it's 214 degrees in the white, which is down the bottom here. The white's hotter than the red, which is initially confused me. Got to look at the chart here. So we need to make some changes to these fins to get the temperature down and get the hotspot away from the bottom. So I'm just going to move out of that and use synchronous to make some changes. So the first change I'm going to make, I'll just pick up that bottom plane there, and we'll move him down like that. I might also pick up that plane and move it out, I don't know, some distance, maybe 40 millimeters, maybe a bit of an overkill. And we also want to add to the pattern. We want to add more of them. I've got 10 of them. Let's make it 15. Now, okay, when we go back to our loads, what we see is where our convection is not picking up all the fins because there's some missing there. So we want to pick up the feature, pick up another one, accept that. We want to remesh and resolve, so we can just hit the solve. It'll remesh automatically and solve. The types of analysis we have, we're looking at the steady state heat transfer, but we can have the steady state heat transfer with linear static or with linear bending, so we can do combinational types of analysis, which is very powerful, very useful. So what we're doing now is as you can see, we've extended the fins, we've made the fins deeper and longer, which should help cool down the hotspot at the bottom here. And let's see what the results tell us. It's about 30 odd seconds as from memory it takes to process this when I put all these extra fins in. It takes a little bit longer. Makes it think a little harder. Okay, yes, we've brought the temperature down significantly. You can see it's cooler at the bottom. It's a bit hotter at the top. We've got a couple of different ways we can display this information as well. We can look at it as an ISO contour. So if we let that recalculate, we can see we've got these ISO color bars going through. Or we can do that dynamically as well. We've got a slider, so we can slide through those as well. And we've still got all the report functions, etc., that we've had in the past. So there we go. There's the hotspot up the top there. So we'd need to modify our design to get to maybe even that out a bit, or it might be acceptable. It's actually not too bad. The temperature spread's only a degree across that. Okay, moving on. Let me just close out of that for you. Back to my slides. With every release of Solid Edge, we do significant amount of work on the draft module. It's what we all use to communicate our designs to people who have got to manufacture them. We use it for checking purposes, everything. Drafting is essential for what we're doing. With ST5, for people who do 3D wire harnesses, so I've got the 3D wire harness add-on, we've added a nail board system. Nail boards are about physically laying out cables. It allows us to take a three-dimensional cable harness, which might have hundreds and hundreds of individual wires in it and different bundles and what have you, and lay that out flat in real size on a thing called a nail board. And there's an illustration of one there. That's exactly what it is. It's in its crudest form, literally nails driven into a piece of plywood, and you route your cables along those nails and then bundle them together. It's a very, very simple system to use. It's quite mind-bending to watch it work, and we'll have a look at that. We've also done a lot of work on bill of material sheets, our parts lists, and the way we process those. And we've always been able to handle large amounts of data, but we've automated this now to break them up and do individual sheets. We'll have a look at that as well, because it's quite complex. While we're on that subject, there's a lot of detail work has been done on these parts list in the parts list area. There was a lot done on ST4. There's more done on ST5. So if you're still on ST3, you really need to get with it. Believe me. Another thing that this has been heavily requested by a lot of our users is to be able to show alternate positions of an assembly in a drawing. So using an alternate position, we automate this, bring it through into the drawing so you can see a shaded view as your base view and the alternate positions in dotted. And again, we'll have a look at that as well. This is a little thing, but something that's been with us for a long time, being able to very easily line up dimensions. Now, there's been all sorts of schemes proposed, and we've been able to use grids and things like that, which personally I detest grids. And what we can do now is line these dimensions and annotations up just by touching with the cursor. So we move across, touch the other dimension with the cursor, and they lock together. We'll see that as well. Just a thought while we're talking about dimensioning, there's been over 250 customer requests for dimension enhancements have been satisfied in ST5. A lot of things, a huge number of things. It's worth looking through, and we'll talk about the resources to look through a little bit later. Okay, let's have a look at these demos. Bear with me for a moment while I work out what I'm supposed to be doing. Let's have a look at nailboard first. So I'll just say new. I've got a nailboard draft already set up, and the thing about the nailboard is it's a background sheet that I've set up that happens to be an 8x4 sheet of plywood in metric, and you'll notice that there's a new tab across the top here called diagram, and I'm going to bring my nailboard in, find the right folder. We're in draft, nailboard, and it's that assembly I want to bring in. And it will automatically flatten that for me, but it gives me some options to begin with. The main run, as it's depicted on here, will be determined by the largest diameter of the bundles that I have, or it could be the longest conductor. It depends on how it's looking, or you can use a select, whatever you want. I'm giving the board, it'll print out in the bottom, a name, width and a height, which I'd already preset, and line styles and things like that. All preset. I'm just going to place my harness. Now, it's just flatten that thing out. It's not going to fit that well. What I need to do is insert some bends, and I can say a radius and an angle, and I'll put my bend in there. I might want to put, still hard to fit in, I want to put another bend in here, and you can see, but just by moving my cursor around, the options I have for placing it, I'll put it in there. Go back to my select tool, and let's just move this thing so it fits a little better on the sheet, about there somewhere. And I might want to straighten that bend out a little bit. Let's go to the bend and pick up one of the points on it and bring that up like so. Okay, we can now move individual bundles like so, and in a similar fashion you'll see that we can bend wires. Now we can't extend those because these are fixed length. They're determined by the three-dimensional model, and these are accurate wire lengths. If we zoom in, you'll see I can move individual wires. Let's do something that's bunched up a bit more. So I want to spread those out a little bit more, so I can very easily spread those. The wire colours are coming through. The wire colours are determined by the wire list that drives the system, etc. Okay, having got my layout roughly where I want it, I might move it across here a little bit, I can now apply my connectors. So I've got a connector that's going to go onto that wire, or onto that bundle. I say next. There's a view I've created with the part file called a connector view, which is looking at the correct end of the connector from this point of view. I can just say finish. Now let's zoom up. It's attached to my cursor ready to place, and it's at 1:1. If I just use my wheel on my mouse, I can increase the size of that. So I'll take that up to 5:1. And again, let's do a connector again on this one. Let's take something a little bit more complex. Take this one. Next, finish, and bring that up in size and place him maybe there. Put another one on here. Next, finish, place him there. We might have another one over here somewhere. I won't do them all, just to give you a flavour of what we have, and place that one. Once we've got these connectors in, we want to do a connector table, which actually tells us what wire connects to which pin and how these are done. Now, when we create the connectors in part for wire harness, we actually give the pins all labels and names. So when I click on there, it will create a table, and it will, as you can see, number all my pins. And then it says, okay, pin number 1 is wire ID is this, and it's the red connector. And if I had previously, if we move this, just by the way, you'll notice the connector moves with it. We can change the position of all the call-outs and move those around as we like. And of course we can spread out our wires so that they're clear to see. So this is telling us how to wire up the connectors for this. You notice when I move that connector, that wire, the connector happened to be attached to that one. That was the one I picked when I placed it. Okay, so you can see what we're doing here. This is pretty straightforward, and it's giving us all this information. So just do a connector table for, say, this one, and for this one, and for this one. We can move the labels around, we can clean everything up. Finally, what I want to put on there is a conductor table. Now, a conductor table is for the whole thing, and if we look at this, this is all the detail that we need to create this. So it says the top bundle, it's coloured black on our drawing here. It's a 1-inch bundle, the cut length is this, the true length is that, and it's made up out of all these wires with these true lengths. So we can have the cut length, and we've got a trimming allowance and a stripping allowance and things on them. So we can cut all the wires, pre-cut all the wires to those lengths, run them into the nail board, position nails on our corners so that it fits around there, and just string all the wires through. So we know that that orange one there goes through to wherever the orange one comes out here. It'll tell us on this wire list. Very, very straightforward. We just tick off each one as we put the wires in, bundle them all up, put the wrapping on them, and then terminate the connectors onto them against the tables. We get a very accurate cable this way. Okay, been enough time on that for the moment, I think. Let's have a look at alternate position. Now, I'll just bring up a blank file here. I'll go to my view wizard. I want to go to draft again. I've got an alternate position, and I want to bring up this chute assembly. Now, this assembly is an alternate position assembly. We've set up some positions for this chute inside the assembly. The draft process, when I open this, now automatically recognizes this, and the drawing view creation wizard picks that up and says, okay, which one do you want as your primary view? I want the closed as my primary view. I want the alternate views to be 15 and 30. And I say next, and I have my normal view wizard here. I want to take a right hand view and just say finish. Now I also want to color this as well, so I want it shaded with edges, and we'll see how that processes it. Now it's bringing all of this through from the assembly for us, and building the building the view. As you can see down the bottom, it flashes through. So what it's done, as we can see, is there's my primary view, and the others are dotted. The primary view is colored, the others are dotted. If I wish to change that, I can right click on the view, in here somewhere is set primary and alternate positions, get that dialog back again, and say, well, I want the 90 degree to be my primary, 90 degree to be my primary, and I want all the others to be displayed. So I say OK to that. It'll go and access the assembly and process it. Then I'll have to update the view. So we need to update the views, and it reprocesses and rebuilds the view. And we see it built the other way around. As you can see, that's pretty straightforward. The key to it is an alternate position assembly, and it just comes in. So it's very little work to do in draft. You've already had to create the alternate position. Okay, let's have a look at the changes we've made with the parts list, and especially the separate sheets. So as usual, parts list, I want to create that. I've preset one in here called new table, and let's look at the contents of that a little bit. So in general, what we'll see is fill to the end of any table we create with blank rows, so it looks like one that's been drawn up. And we're going to create new sheets for the table, and those sheets will automatically flow over. So the first sheet will be a sheet called BOM. There's all our sheets. We've got one called BOM. and it will continue that over. So we're all set to go. We've got the parts list, place parts list turned on, and I click. What we see is the balloons get placed, which is normal, but you'll notice now that none of the leaders cross over, and they're a lot cleaner. The other thing that's happened is that we've created these tables. So we've got two tables because it's a top level assembly drawing, and the table ends here, but we've got the blanks filled in. If we go back and make a change to this, from here, if we look at the properties of that table, go to our list control and change that to an atomic list, so we're going to create a bill of all parts, say OK to that, what we'll see is very quickly it populates all these tables up to table 14, and again the blank rows are there. So you can see that's quite powerful. It's there's some very useful changes being made there. Anybody who's dealing with builds of material, being able to set up your build sheets and have them fill like that automatically will be very useful. Okay, one last thing I wanted to show you while I was here is let's go to the view wizard. I want to pick up just browse for a part in here. Okay, and I want to show you how we automatically fold the views on the cursor and do our alignments on text, and dimensions. So just opening that, take our right view. Those views speak. I think that's Spanish, isn't it? And just finish. I want to make that a bit smaller. We'll make that 1:1 and place that. So there's my first view, and you can see it's folding the views off. They're just on the cursor. I haven't clicked any other. I'll put one up there. So very neat, as you can see. But what I want to do here is to just zoom in here a little bit, and we'll place some dimensions again. So using our distance between, pick up the center of there to the center of there, place a dimension. And again, I'm going to pick the center of that to the center of there, and I want to line those two dimensions up. So I just touch on this one, and you'll notice it sticks, it snaps into place, and there's a little alignment line. Again, if we're doing one this way, so I use the shift to put the angle in, and I'll put another one, but I'll put that somewhere else, and later on we come back and we want to align those. Again, I just move that dimension the normal way, click, touch on the previous one, and it'll align to it. So you can see that ability to be able to align our dimensions after the fact is very powerful. Move that one out. I want to move it so that it touches or lines up to here. Again, you see the alignment line, and it's lined up. Okay, back to our slides. Just close that down, and as I said earlier, there's been a large number of enhancements, and 1,300 over 1,300 enhancements have been added to this, and a lot of them have been customer driven. So there's over 200 requests 220 requests in part modeling, 350 in assembly, 570 in drafting, and over 200 in other areas. These would be things like data management, etc. So there's been a lot of work, as you can see. One of the first things that we want to look at is our mirror assembly command. That's been enhanced significantly in lots of areas, but most noticeably is the associativity. So it's an associative mirror now. When you change something from the where we're mirroring from the left to the right, here we change something on the left, it'll update on the right. I think you're going to find that very useful. Assembly relationships, we've got a lot of new relationships, and we've enhanced a lot of existing ones. Most noticeably is the path relationship, doing things like barrel cams and sliding along 3D parts. A connect relationship has been significantly reworked, and we've got a glue. We can glue parts with a rigid relationship now. That's extremely useful. We'll have a look at some of those in a moment, so panic not. And a new environment we have, it's more than a command, it's insert assembly copy. It's very similar to insert part copy, but it brings in an assembly into another assembly. It's not a sub-assembly, and it's fully associative to the original. It puts all the content but does not add the source itself. So it's an instanced copy. We've got control over what comes through, so we can include or exclude various parts. We can add new components on update. So if we add a component to the master, then the copy will update. We can include assembly features. We can even mirror the thing. It's very powerful for reusing things like framing, piping, and general assemblies. It's quite spectacular. We'll have a quick look at that. And we've reworked the replace part command entirely. So you can replace a part now with a standard part. You can replace it with a new part. You can replace part with copy. We'll look at that in a moment. And of course the old replace part command. But replace part with a copy is where we've got one of the parts. We've got, say, several parts instanced into the assembly. We want to change one of them, put a slot in one of them, or a groove, or change its length or something, but we don't want to do it to all of them, so we need to create a new part number, and it lets us do that. So we'll take a look at that. And switch over to Solid Edge, and cancel out of that. And what do I want to look at? What we're going to do is we're going to take this roller table and make a copy of that. It's just an ordinary assembly. It's got some frame components in it. Nothing too unusual. So I've got another assembly here, which is just a copy assembly that I've set up. It's got nothing in it except a user coordinate system. So let's use this new command. It's up here on the clipboard, which we expect, and I'm going to copy it's in this folder, this one, and I want to make a copy of this roller table. So we open that, and it brings up the dialog box. Now I want to make it associative, include assembly features. The coordinate system I want to use is this coordinate system 2, so I want to attach it to that coordinate system. Now I'm going to select these swivel casters because I don't want those come through, because we're going to put a different mechanism on there. Right click, and we're going to say exclude those, so we're excluding all of those. OK, and it's instancing a copy of this assembly in here. You'll notice it's an assembly copy. We have a new assembly, and this is not a sub-assembly, it's just an instance of those parts. So let's bring it up so we can see it, and I want to bring in from my parts library this skid. So it's capture fitted, and I want to align it to that hole and to that hole. We'll bring another one in. I don't need to go to the library, just bring the same one in again. Capture fit, and it's right hole and that hole. So we've got a new assembly. It's got its two parts in there with its relationships, etc. Let's just go back to the original assembly, to my roller table. What I'm going to do now is I'm going to edit this frame. We're going to just change the component in here. So in these extrusions, I'll just use a 40 by 40, which is a smaller extrusion. Say OK to that. I can't say extrusion. Let it update. We'll see that smaller extrusion come through there. OK, so we've got the small extrusion on the top. Get out a frame, and I just want to create a feature, just to cut out just an assembly feature on the base here, and we'll just make a circle. I'm not too worried about how to position this. And punch that hole through. Okay, so when we return to our copy, we'll see it's updated with those parts, the new frame part up here and the cutout. So we've got two assemblies that are just this one's reusing bits of the other one and creating its own environment. That's quite useful. Okay, one more thing to look at is let's go back to our our original file here. And what I want to do is mirror these components across that I've just created. So if we go to our pattern command and pick up the pattern, and I want to mirror about something, so just let me turn on a reference plane here, the center plane, and I want to pick those two sub-assemblies and the plane that we're going to mirror across. Now Solid Edge is smart enough to work out that one of these parts has to be mirrored. So the sub-assembly it has to make a new sub-assembly, and it'll be called the same name but underscore mirror.assembly, and the part will get changed as well. This part's just going to be rotated, so it's not going to have to be recreated. You notice we're recreating files here, so if we say OK to that and finish, we actually go and generate all those part files and sub-assemblies, and it'll go into a collection here called mirror, so we can identify it quite easily. So we'll see that come up in a moment. You notice we get a preview in grey of what's going to happen too, which is quite useful. So there's our mirror and our two new sub-assemblies. Now let me just zoom in a little bit and do what I did before, dragging a component. I'm just going to do this again, and you should see the opposite one update. So any changes I make to here will get reflected. Any other changes I made to parts or anything else would get reflected across here as well. So it's an associative mirror where it wasn't in the originally. So quite nice, quite nice. Now the final thing I want to look at is the ability to be able to create a new part from an existing part on the fly. So if we look at our replace part command, you notice we've now got a drop down arrow and we've got replace part. The one I want to look at is replace part with a copy. So if we look here, we've got this arm and that arm, they're the same as each other, and I want to make a slot in this one but not this one. So I will use replace part, not replace part, replace part with copy. That's this one. Tick it off. Brings me up a dialog. What do you want to call it? Well, I'm going to call it arm underscore slot. If I can spell slot, S-L-O-T, and save that. And you'll see now that this is called arm with slot, and this is the arm. So we've got a new part in here. Okay, let's edit that. And I want to create a slot in there, so we'll just make that slot. We need to go to the dialog. I don't want any countable or recess on it. I want that to be 20 millimeters from memory, round end. Okay, close and return. Now let's apply a relationship to this. So go to our assemble command, and what I'm looking for here is the path relationship. I'm going to pick the center of that, but what I want to find is the center axis of that, and then on this slot, if I rotate that away a bit, you'll see the center line of the slot, and OK to that. So what we've got now is this relationship on this part that will allow that to operate. So let's simulate that. I've got a little motor simulation here, so let's run that. And we can see that behaving. The interesting thing about this this relationship, this new relationship, is that it's going to allow us to do some interesting things. This path relationship will in effect replace in a lot of instances the range relationship that we brought in ST4. It'll work better in most cases than the range because it won't have as much overhead, and I think that can be an advantage. Okay, back to the slides. As you can see, ST5 is a big release. It's over 1,300 changes. You're not going to pick them all up at once, but there's some resources out there to help you. We're going to have more clinics, obviously, as I said before. The next one's likely to be on our multi-part environment. There's the ST5 release notes. There's a link to them. It's in the documentation area on the GTAC site, ST5 release notes. Get those, print them out, use them as your Bible. There's a lot of good information in there, and of course the self-paced training. All the self-paced training now is up on the web, up on the link, the website here. And of course, don't forget, we have training courses. We have fundamentals for ST5, ST5 what's new, framing, sheet metal, surfacing, and we can do bespoke courses for people who want to, say, become familiar with synchronous technology. Those are available as well. So, question and answer from this recording. We'll take that out because it just takes too long. Next time, 2 weeks hence, we will have a clinic on the multi-body environment, and it just remains me to thank everybody for their time, attention, and patience while we got these clinics back online again. Thank you very much, and good afternoon.